consider the nth term as 3 times the previous term plus n minus 1. We are given T1 and want to find T100. So on the face of it, it looks like a pretty easy series question. T1 is 3, T2 is thrice of the previous one, plus n minus 1. N now is 2, so n minus 1 will become 1. So don't find the final value of this. Leave it in this raw format so that we can match up or we can recreate a relation. T3 is 3 times the previous one. So 3 into 3 plus 1. This entire bracket is the previous one plus n minus 1. This time n is 3, so I have a 2. So the pattern is okay, so thrice of the previous one. Let me use a square bracket. 3 times 3 into 3 plus 1 plus 2. This entire thing is the previous one, so n minus 1 in this case will be 3. Okay, so looking at this 3 raised to 100, 3 raised to all powers, so I'll keep the term as powers of 3. 3 raised to 1 is obvious 3. 3 into 3 is a pretty clear 3 square plus 1. You have 3 into 3 into 3 is equal to 3 raised to 3. Now for the number 3 into 1 3 plus 2 5. So let me take it as complete 5. 1 2 3 4, that will become 3 raised to 4 plus thrice of 1 3 plus 2 5, that is the previous one. 5 3s are 15, 15 plus 3 18. Okay, so by this logic, students, t raised to 100 is obviously something like 3 raised to 100 plus a number. Now this number is pretty difficult, but what we can definitely see is it is a number which is greater, the term is greater than 3 raised to 100. So option 1 is obviously not my answer because it's a subtraction, students, right? So 1 is not my answer. This is also a subtraction. It's less than 3 raised to 100. So B is also not my answer. But then in the D, what we find is 3 raised to 100 has become 3 raised to 101. It has become the next power. So it's become a higher value. So minus, if you could subtract, it is going to come down lower. So it may be the answer. And I'm worried about where do we get this 2 also. Here also this 3 raised to 100 has been multiplied with this 5. Okay, and when you multiply the number, it becomes a larger number, and from a larger number, it's possible that you subtract and then divide and get to an answer. So this also could be my answer, but I have no clue about how to get this 5 and 4. So at least not now. So this is where the question becomes really terrible, students. Yeah, and it's a tough one. When I first tried to recreate the 4 or the 5 or the 200 seems pretty easy. 100 into 2, 200 plus 1. But there was no way that I could recreate 5, 4 and 2. Yeah, to sort of fix, to plug in like an option, right? So only in the second attempt then, when I tried to analyze the series of this number that we get. So I looked at the series. The powers of 3 are obvious. So I looked at 0, 1, 5, 18 as a series. And I thought of, let me find the term here as a series question. So any series, one of the first step that we do is we check the differences. So the difference here is 1. The difference between 5 and 1 is 4. The difference between 18 and 5 is 13. Now this second series immediately gets to, you can capture the pattern here. So 4 2s are 8 plus 1, 9. 13 2s are 26 plus 1, 27. Right? And this 27, 9, obviously there is something to do with this 3. Right? And if you are still not clear, what we are saying is the difference of the differences is 3, 9. You want the next term? Let's find the next term. P5 is 3 times the previous one. 3 raised to 5 plus 3 times 18, 54. 54 plus n minus 1, that is 4. 58. So the next term here is 58. The difference between the two terms are 40. The difference between the differences is 37. So obviously the third series here are powers of 3. So the second series here is sum of powers of 3, students. Sum of powers of 3. So powers of 3. So if you look at the first one is 3 raised to 0. The second one is 3 raised to 0 plus 3 raised to 1. Okay, the third one is, so I'm just adding this 1 year so that you can see the pattern more clearly. This 13 is nothing but 1 plus 3 plus 9. The 40 is nothing but 1 plus 3 plus 9 plus 27. Okay, so the nth term of the second series is nothing but sum of n terms of powers of 3. Right, the first term is sum of n minus 1, sorry. The first term is sum of 3 raised to 0. The second term is 3 raised to 0 plus 3 raised to 1. Right, so the nth power, the series here is going to be the term is going to be 3 raised to 0 plus 3 raised to 1 plus so on till 3 raised to n minus 1. And from your GP fundas, you should know that this is simply going to be the next power minus 1 by 2. Okay, now I'm not going to explain this part here, student. If you're doing such a difficult question, I would expect you to know this offhand. You could just directly write it. Sum of powers of 3 is the next power of 3 plus 1, right? You want to fit it in, you can always plug in 1, 2, 3, 4 and check, do you get 1, 4, 13, 40. But that would be too tentative of you, right? Rather, I would go ahead and do, what about the first series? The first series is the summation of the second series. So the second term is summation, is the first term here. The third term in the first series is sum of 2 terms of the second series, 1 plus 4. The fourth term is the sum of 3 terms of the second series. Check 13 plus 5, 18. So the nth term in the first series, the nth term, is going to be the sum of n minus 1 terms of the second series. And the sum of n minus 1 terms of the second series is going to be sum of powers of 3 till 3 raised to n minus 2. So, what is the sum of the powers of 3 till 3 raised to n minus 2 is going to be the next power 3 raised to n minus 1 minus 1 by 2. So, this is the term in the first series. Okay, and how do you find this? You split it up. There's a half, so that half would come out, and then you're doing summation of n minus 1 powers of 3. Okay, so that would be the next power of 3, that is 3 raised to n minus 1 by 2, minus half is again taken common, right, and summation of 1. Summation of 1 is nothing but n, right? And you can do a check here. So this is a place where I would do a check and not here. This is very easy, students, right? The check here is if I put n is equal to 1. So 3 raised to 1, 3 minus 1, 2, 2 by 2, that is a 1. So this is half minus half, I get 0. And is my first term 0? Yes. Put n is equal to 2. 2 square 9, 9 minus 1 8, 8 by 4 is a 2. 2 minus 1, 2 minus 1 is a 1. So is the second term 1? Yes. Put n is equal to 3. So if I put n as 3, 27, 27 minus 1, 26. Now 26 is not divisible by 4, so there might be some difficulty here. 26 by 2 is 13, but this is also 3 by 2. So 13 minus 3, 10. 10 by 2, we get a 5. Is this 5? Now it is pretty apparent that this is my answer. So what is the 100th term going to be here, student? The number that we are going to fill here, just put in n as 100 here. So I'm going ahead and writing it 3 raised to 100 plus. Put n as 100, so I'm going to get 3 raised to 100 minus 1, okay, by 2, sorry, 2 into 2. Okay, minus of, put n as 100, we said, right? 100 by 2, which is 50. And now it is a very easy task. So you'll take the LCM. Sorry, did I do the divide by 2? Yes, I did the divide by 2. So the LCM is 4. Now I know how I get this 4. So 4 times 3 raised to 100 plus 1 times 3 raised to 100 is 5 times 3 raised to 100. Okay, and the minus 1 will remain as it is. This will get multiplied with a 4, so you will get a minus 201. My answer is C. So it was a tough series question, but it helped me. I think so. This part here is a very nice learning. How can you so quickly come up to powers of 3, sum the powers of 3, sum the summation of powers of 3, students.